Solve second order homogeneous linear equation, differential equation with constant coefficient. The differential equation is given second derivative of y with respect to x plus 8y equal to 0. Suppose this is equation number 1. Let the solution of the second order homogeneous linear differential equation with constant coefficient is y equal to e to the power mx. Then the first derivative of y with respect to x will be equal to m into e to the power mx, and the second derivative of y with respect to x will be equal to m square e to the power mx. Now you put the value of y and the second derivative of y with respect to x in equation 1. So putting the value of y and the second derivative of y with respect to x in equation 1, we get, for second derivative we have find out m square e to the power mx. So m square e to the power mx plus 8 into, because the second term is 8y, so 8 into y value, we have taken y value equal to e to the power mx. So 8 into e to the power mx, that will be equal to 0. So if you take e to the power mx common, then in the bracket you have m square plus 8, that is equal to 0. Since e to the power mx is not equal to 0, because that is the solution of the equation, that is why e to the power mx is not equal to 0. So m square plus 8 will be equal to 0. Suppose this is equation 2, and this equation 2 is called auxiliary equation or characteristic equation. Remember, equation 2 is called auxiliary equation or characteristic equation. Now you solve equation 2, that is the auxiliary equation, to find the value of m. From the auxiliary equation, m square plus 8 is equal to 0. So m square is equal to minus 8. So m will be equal to plus minus 2 root 2 into I. I is the imaginary number. So you have two roots. One is imaginary roots. One is m1, that is equal to 2 root 2 I, and another is m2, that is equal to 2 minus 2 root 2 I. Since the two roots are imaginary or complex, then what will be the solution? The solution we have taken y equal to e to the power mx. So first one will be equal to e to the power m1x, that is c1 into e to the power m1x, and the second solution will be equal to c2 into e to the power m2x. So y will be equal to c1 into e to the power m1 is 2 root 2 I. So 2 root 2 I into x plus c2 into e to the power minus 2 root 2 I into x. So you have two roots, and we know e to the power ix, that will be equal to, or e to the power I theta, that can be written in this form, that is cos theta plus I sin theta. That means e to the power 2 root 2 ix will be equal to cos 2 root 2 x plus I sin 2 root 2 x. And the second term, this one will be equal to c2 and e to the power minus I theta. This will be in the form of e to the power minus I theta, and the expansion is cos theta minus I sin theta. And here you write cos 2 root 2x minus I sin 2 root 2x. So now you solve it to find the value of y. If you take cos 2 root 2 x common, then in the bracket you have c1 plus c2, and if you take sin 2 root 2 x common, then in the bracket you have I c1 minus c2. So if you take c1 plus c2, another constant c, and c1 minus c2, I into c1 minus c2 is equal to another constant d, then the solution of the given second order homogeneous linear differential equation with constant coefficient is given by y equal to c into cos 2 root 2 x plus d into sin 2 root 2 into x.